Eksi 7, eksi 1, artı 2, eksi 2. Artı 9, eksi 3. Now, we need to do the two-phase. So to be able to do that, we have to start by writing this, because we already know that in here we have minus E1 plus A1 minus E2.
Tahtayı göremiyoruz şu anda. Kamera çok uzaktan gösteriyor.
Okey, bir bakalım. Kamerayı bekleyeyim şey yapana kadar zoom yaptı. Tamam. Değişiyor çünkü kafasına göre zoom yaptığı için kamera. Şey belli olmuyor. Şu an gözüküyor
duality
mu?
bitti mi şu an konu olarak?
Dual alma bitti. Dual simplex başlayacak. Dual simplex farklı bir konu. Ona da geleceğiz sonra.
Tamam o zaman.
Şimdi, now, we already know that we have to minimize A1 plus A2. And we have those and 3x1 minus 2x minus E2 plus E2.
Uzaklaştı hocam kamera.
Efendim?
Kamera yine uzaklaştı ama şu anda görünüyor.
Gelir birazdan geri diye umut ediyorum. Neyse diğer kamerayı deneyelim o zaman. Böyle deneyelim o zaman. Şimdi bunu tabii ki standard form'a çevireceğiz. We have to convert this into standard form and then into this is standard form and then into the table anyway. So we will have z x1, x2, x3, e1, e2, a1, a2 and the right hand side. We have a lot of. So we will have. Doesn't matter. Let me just. Yep. So that we don't make any mistakes. 1, 2, minus 1, minus 1, 0, 1, plus 0, 5, 0, and now we have 0, 3, minus 2, 0, 1, 0, 1, and then 7. Now this is a starting table. I'm guessing you all have found it like this anyways. And we already know that we have to get rid of those minus ones because we have to find the identity matrix which is over here, which means that these values should be 0. So I will just add these two rows to the top side and I will get, say, 1, 4, 0, minus 1, minus 1, 1, 0, 0, 12. Now, this is my current row 0. So I will start from here and I will try to minimize A1 and A2. So to do that, we will start with 4, which is the greatest positive value, and then I will just pivot, which will happen over here, 7 over 3. After you pivot this and you keep going, from here on, it's all normal simplex. We don't need to do anything else. The two-phase part in the first phase has started with these minus ones being converted into 0, and then it's all normal simplex. And after we are done with normal simplex, we have done the iterations. I will not do the iterations because it will take a lot of time. But after we are done with the iterations, we will get this one. Let me just write it over here. X1, X2, A1, E2, A1, E2. Right hand side. Now, it's always one, it doesn't ever change. So then I will have a lot of zeros. 1, 2, 3, 4. Yes, yes. minus 1s once again, and that'll be 0 over here, 1 and 3 over here, and we'll have 0, 1, 1, 0, 0.125. This is taking a lot, even though it's just a shortcut. If I had to do it by hand, I would probably waste, I don't know, 15 minutes, 10 minutes, depending on how fast I write. But with Excel or with anything else, it just takes 3 or 2 minutes tops, because all you have to do is just write all the equations, all the formulae, and it just instantly, almost instantly, calculates everything for you. So, minus 1.25. But if you did everything by hand, as I said, it would take 10 to 15 minutes, maybe more, depending on how fast you write. Minus 0.25. And then we have minus 0.25, 0.25, and 0.25. Now, this is the optimal solution for the A values. And from two phases, before we get to the second phase, we know that if both all artificial variables are non-basic, we will just remove them. So these get to be removed from the solution anyways. And then we add the original objective function in here. Now, the original objective function had 7 plus 2, minus 7 plus 2 plus 9. So when we convert it to standard form, it's going to be 7 minus 2 minus 9. So everything else over there is going to be 0 anyway. So 0 and 0. We don't need A1 and A2 anymore. But, oh wait, this over here isn't 0 right now, it's minus 19. No, it's 0, sorry. But when you take this one, you have to check if there is any problems with the original identity matrix, which was here. So yes, there's a problem. This is 7 and this is minus 2. So I have to get rid of these values. This should become 0 and 0 once again, which means that I will just take this one, multiply it by 2 and add it here. Take this one, multiply it by 7 and remove it from here, so minus 7 or add it over here. So if I take minus 7 from this one, I will get a 0 over here. If I get 2 and add it over here, multiply this row by 2 and add it over here, I will get another 0. And over here I will have minus 19. Now, if I write everything else from these, I will get 0, 1, and 2. Now, this one is my current row 0 over here. So if I take a look over here, I have the identity matrix, which means that x1 is equal to 3, x2 is equal to 1, and z is equal to minus 19. This is the solution that everyone has found, but there is a 0 over here, which means that x3 can enter the solution. And if you take the pivot from here, you will see that you take the pivot in here actually, and what you get is at the end of the iteration. If you make the iteration, what you get is the same value. So z is equal to minus 19 anyways, and in the first one, x1 is equal to 3, x2 is equal to 1. But in the alternative solution, you will get z is equal to minus 19 again, but this time x1 is equal to 13 and x3 is equal to 8. Now, with these two, you can form the alternative solution, linear interpolation, let's say. And what you do is just multiply this solution by c and multiply this solution by 1 minus c and add them together. So what you actually get is, let's say that this is 3, 1, 0 times c plus 1 minus c times 1308. This is the optimal solution with alternatives, of course. For any c value between 0 and 1, you will get a z of minus 19. So this is what everyone missed, the 0 over here, the x3 in the x3. So if you did that, you would be getting 25 points, full marks. But most people, missed it. Not most, but everyone missed it. Everyone that could have found it, that had come over here, missed it. So yeah, Actually, the fourth question would be the one you get most marks. It still was the one you got most marks, but still I was expecting a higher difference with the second question. The second question was a bit harder than the fourth, in my opinion, but still they got almost the same amount of points. So what about the third one? The third one was actually a bit different, and I'll just show you the from the shared screen. There you go. Now, as you can see, in the third one, what you had to do was just write the intervals or the values. If there's only one value, you would have to write that value, which is like 0 or 1. There are no other values that you can write over there. But if there was an interval like less than 0, which means that minus infinity to 0, or greater than 0, which means that 0 to plus infinity, you had to write those intervals as well. You could have left these minus infinity, plus infinity parts like empty. It would be filled with those anyways. So the thing over here is, all you had to do was just turn in a blank table like this as your answer, and you will get, I don't know, 8 or 9 marks, because as you can see, these are all, if they are left blank, they will be just filled automatically with minus infinity to plus infinity, which will give you 9 points from these calculations. So what you had needed to do was just find those values. There are more than one way of finding these. For example, I said that this is greater than 0. Some of you have said that this is less than 0. That's acceptable as well. If it was less than 0, it's still infeasible, so it's okay, no problems there. But my personal answer was greater than 0. I didn't expect you to, copy paste my answer, but there are some people who have found them almost as exactly the same. But there were other ways you could have found, and I gave full marks to them as well. But still, not many people got 25 points out of in this one. And in the second one, the second question was a bit more easier, and most of you have found this, but there were a few problems in there. If you can remember the question, it was talking about getting a worst case profit, and duration and etc. And it was talking about less than 6, greater than 8, etc. As you can see over here, for the duration to be less than 6, what you had to do was just take the weighted average. This is like a blending question, not like a blank, but it's a blending question for these two constraints. So what you had to do was just take their weighted average. Now here, if you have made the same mistakes, you just took those values and just divided them by 4, which is not logical, because the sum over here is 1 million. You know that. The total investment is 1 million. If you had said less than or equal to 1 million, that's okay as well, because this is the top, this is the highest value you can, invest. But I want to invest everything, so I just wrote equals to 1 million, but you could have wrote less than or equal to 1 million, that would be okay as well. But if you do less than or equal to 1 million, you have to do it like this. If you write less than or equal to 1 million, you have to do it like this. If you write equals to 1 million, you can just divide them by 1 million as well, because you know that this sum over here, the x1 to x4 sum, this sum over here is already 1 million, because you already said that it's equal to 1 million in your constraint. So you could have written over 1 million, or you could just write 6 times 1 million, etc. Now, the x's over here are the amount of money invested, so they can be greater than 100,000 and less than 400,000. Now, over here, some of you have made the mistake of summing everything and saying that they're all greater than 400 and less than 1600 or something. So, yeah, some sort of mistake over there. I don't remember everything right now, but still, these x1 to x4 values are all greater than 100,000, which means that they all have to be invested in. You invest in all of them. This forces you to invest all of them, because it's greater than or equal to 100,000. And this less than or equal to 400,000 gives you a interval to invest in anyways. But still, these let's say these 4 constraints and this objective function, they all had 5 points. So you got points according to those. Some of you got partial points from some constraints, of course, but still, these were these 4 constraints and this objective function, they all had 5 points anyways. Now, what about the first one? The first one is a bit harder, but it isn't that hard anyways. So let's just take a look. Now, if you remember the question, you had to form 2 teams, and for those 2 teams, you had 23 or 29, yeah, 28 people. So you had to pick from those 28 people. So there are a few different ways of doing this. It all depends on how you pick your decision variable. For me, there are 2 different ways of picking those decision variables, either with 4 indices, ijkl, or with 3 indices, ijk. I prefer the 4 indices part, the difference being in the class. So if I add a class over here, this changes the number of decision variables drastically, but also decreases the number of, let's say, constants that I have to write, at least in closed form. But by removing that class, I, let's say, decrease the number of decision variables I have to use, but increase the number of class constants I have to write. So I prefer this one to write less class constants. You will understand what I'm talking about in a second. But in here, the thing is, for example, for the first one, let's start with the first one. There's a that night, the number 1 is a that night. So if that night the class is 1 as well, if I take this as class 1, it means that x11 is going to be 1 at some point if it's selected. But x12, whatever the k and l values are, is always going to be 0. Because the first character, the first number, is never in the second class. It's always in the first class. So all the classes over here, I don't know, 10 classes I think, all the classes over here except x11 are going to be 0. x11kl, that's right. So x13kl, x14kl, these are all 0. I know that, I'm sure of that, because that character is only at that night. It cannot have any other attributes, so these are all 0. So this one might be 1. There's a possibility, it's not certainty. But this can never be 1. So I have excessive decision variables, but it doesn't really matter as long as I know that these are 0. I don't mind. They can be there. It doesn't really matter, but I have to make sure that these are 0 because with pijk, so I have a number of character, class and role. Once again here, I can get rid of the j over here. I can just write pik if I want to, so that I will only have the performance indicator depending on that role. But writing j is going to give me a bit more, certainty with ignoring the classes, because as long as this pijk is equal to, for example, p11k, depending on the k, I will get a number from here. If k is 1, I will get 50. If k is 2, I will get 0. If k is 3, I will get 100. Cool. But for every k where j is not equal to 1, this value is going to be 0 anyways. So it's always going to be 0 because that character cannot be in that class, so it cannot give a performance rating above 0. It's always 0. So by writing it with 4 indices, the decision variable with 4 indices, where the decision variable is 0 or 1, or between 0 and 1, because we are talking about linearity here, but we can just assume it's binary 0 and 1. Doesn't really matter, at least not in the sense of logic. But if it was 0 or 1 only, then solving it would be a different algorithm. We wouldn't be able to use normal simplex in there immediately. We would have to change a few things. But still, 0 or 1, less than 1, they're all okay. So yeah, I just have to write ejkl is less than or equal to, let's say like this, 1. So if I say it's binary, it's okay as well. I would accept that one as well. It doesn't really matter. So back to here. First, we have to find out the size. There are 2 teams with size of 5 and 14. So what I have to do is just sum every xijkl for l is equal to 1 into 5. So sum ijk into 5. And then the same thing for the second team. So for the second team, sum ijk into 14. So I have the size constraints done. They are equal to 5 and 14. I know that that's not going to change. Then I have to find the class constraint, class number. I know that for the first team, there can only be 1 of each class. So for all classes, the sum should be less than or equal to 1. Why less than? Because there are 5 people there, so 5 classes will be there. I don't need all 10 classes, so some of them are going to be 0 anyways. And with here, I'm saying that the number of classes cannot be more than 3. The sum number of characters in the same class cannot be more than 3. So ijk for the second team is going to be less than or equal to 3. The sum of ijk for the second team. So we're done with the class constraints anyways, and then the composition constraints. We know that we need 1 tank, 1 healer, and 3 damage dealers for the first group. So take a look over here. The K value is 1, 2, and 3. So this is the tank, the healer, and the damage dealer numbers, which are going to be 1, 1, 3. And for the second one, the composition is going to be 2, 3, and 9. So we will get the second team is L is always 2, and K is going to change 1, 2, 3, which will give us 2, 3, and 9 with the sum of all the X values. And for the maximization part, we want to maximize the performance value, so we'll just multiply performance with xijkl and sum it all indices, which is going to be our maximization objective function for maximization. And this one over here is of course the sign restriction. You can take it as a sign restriction, but it just restricts you between 0 and 1. Okay? You could have
Hocam
written
bu bir
as a
kere seçebilme şeyi mi? Şu hani smaller than
Efendim?
one. Smaller or equal to bir kere seçebilme mi?
Evet, aynen öyle. Aha.
Teşekkür ederim.
Bunu binary de
Ben onun
yazabilirdin.
küçüktürü unuttum galiba. Öyle bir şey.
Olabilir.
Akıllıca.
Bunu binary de yazabilirdin. 0-1 de olabilirdi. Ama binary'de lineer çözüm olmuyor. Ama binary yazmada da bir sıkıntı yok. Hani lineer çözüm olması şey değil. Bu tip soruların hepsinde bu küçük eşittir 1 yazdığın zaman lineermiş gibi varsayıyorsunuz. Bu size şeyi veriyor. Hani 0,5'te olabilir ya, bu yarısını seçtim bu adamın falan gibi bir şey deme şansı oluyor. Tabii o olmayacaktır sonunda işin, ama hani bunu verdiği için ya bu lineerleştirmek adına olur söyle adını, gerçekliği yok ettik falan gibi bir şey yaratıyor. Söyle adını, sıkıntı yaratıyor. Fakat önemli değil. Bunun küçük eşit 1 olması yanlış değil sonuçta. Bu 0 or 1 yani binary yazsak da yanlış değildi.
Yanına binary yazabiliyoruz yani. Normal kod
Evet,
olarak
yazabiliriz.
yazsak.
Evet yazabiliriz. xijkl binary deseniz de tam puanı sonuçta fark etmeyecektir. Ki bayağı yaklaşanlar var. 1-2 tane constraint'te ufak tefek hatalar yapıp da böyle 20'lerde falan kalanlar var. Ama buradan da tam puan olmadı. Diğer soruda, 4. soruda da olduğu gibi. Ne yazık ki. 2'den en çok tam puan çıktı tabii ki. 2'de bayağı tam puan vardı. 3'te de tam puana yakın olan çok vardı. Ama yine de en yüksek şeyi 4. sorudan aldınız. En yüksek getiri 4. soruda vardı.